worksheet. Was everybody able to pull up this worksheet? It's in Google Classroom. Can you all hear me still? Yes. Okay, awesome. All right, so if you want to open that up, I'm going to use this throughout the lesson to show you what we're doing, but that's where the problems are that you're going to do. So we're going to go through the first one together, and then I'm going to have you stay on the line with me and work through the second one and the third one to see how you do, and that way I'm here to answer questions if you have them. All right, so this table here is a list of known bond energies. So this is how much energy it takes to break a particular bond, or also the amount of energy you get back if you form that particular bond, or the amount of energy released. Okay, so we're going to start with this question here. The number 1, that's what we're going to work on today as a group. Okay, and so I'm going to go down to my blank page and rewrite that equation. All right, so number 1. And bear with me because handwriting on this iPad just looks awful for me. All right, so we have CH4 plus 2O2 makes a CO2 and 2 waters. Okay? So you should all have paper and pencil out and be taking notes on this, so that because you're going to turn in this problem as well, right? This is number 1. Okay, so the first thing that we want to do with all of these problems is figure out what bonds do we have. So in order to do that, we need to draw the structures. So further up on our sheet is the structures of all of the molecules you might possibly need for this specific problem. So we're going to need this one, which is the CH4. All right, we're going to need O2, which is right here. All right, we're going to need CO2, which is here, and we're going to need water, which is here. So they're all right here in the corner together. Okay, so I'm going to draw all of them down on my sheet, and you should draw them on your page as well. So CH4 looks like a carbon with 4 hydrogens bonded to it. Okay, and we just have one of those. O2 looks like 2 oxygens double bonded together. Okay, it's important that you take a look at the sheet and know which one we're using, because you're going to need that double bond. A double bond is different than a single bond or a triple bond. Okay, and we have 2 of them. So even though it feels redundant, I'm going to have you draw it twice, because that will help you count the bonds properly. Okay, and then for our CO2, that is an O double bonded to a C, double bonded to an O. Okay, and then our water is going to be an H with an O with an H, and we have 2 of those, so I'll write that 2 times. Okay. Everybody with me so far? Give me a thumbs up or a yes in the chat. Awesome. Okay. So now what we need to do is count up the bonds we have and add them up. Okay. So in methane, we have 4 CH bonds, right? Each line represents a bond. So if we look up in our table, a CH bond is right here, right? And that's 413 kilojoules. So to break one of those is going to be 413, but we have 4 of them. 1, 2, 3, 4. All right, so each one of those is going to be that much energy. Okay, now over here for our O2, we're going to go up and we're going to find O double bond O. All right, so there's an O single bond O here. That's not the one we want. All right, that is not the same as a double bond, and 2 single bonds is not equivalent to a double bond either. So you actually want to find the one that's the O double bond O, which is over there. So that's 495. right? And we have 2 of those because we have 2 O2 molecules. Okay, so all together on this side, that's how much energy we're going to absorb when we break all of those bonds. So I like to draw a little squiggle between my 2 sides of the reaction so I can make sure I keep them separate. All right. So on this side, we've now done everything on the left. We've broken all the bonds and the reactants. All right, so if we add those up together in your calculator, you should get 2642 kilojoules, and that's going to be how much is absorbed. Right? Because we absorb energy when we break bonds. Okay, now we're going to do the same exact thing on the other side. So here we have CO2, all right? So we have 2 C double bond O, right? This one is a little bit tricky. I don't know why, but there is a CO here in our table, right? But there's also a little asterisk which tells us that if we have a C double bond O in CO2, the amount of energy is just a little bit different. Okay, so instead of being 745 for the bond, it's 799. So we'll use that number. If I were to give you this on a test and you use 745, I wouldn't take points off just because it's a little confusing, but we're going to do it the right way since it's the example. All right, so that'll be 2 times 799, right? And then last but not least, we have water. Water only has OH bonds. That's the only kind of bond in it. So we're going to go up to our table, find an OH bond. All right, that's here. All right, so it's 467. All right, and we have 1, 2, 3, 4 of them. This is another reason it's important to draw them because it helps you keep track of the bonds you have a little bit better. Just looking at 2H2O, it might not be obvious just looking at the formula how many bonds you have. All right, so when we add those up in my calculator, I get 3,466 kilojoules. And in this case, that's how much is released, okay? Because we're forming all of the bonds in the products. All right, now the last step is to compare the two. All right, we obviously are releasing more energy than we are absorbing, right? That number is bigger. Okay, so we're going to look at the difference between those. So if we do 3,466 minus 2,642, you get 824 kilojoules. That's your net energy transfer. All right, and it's going to be released because the energy on the product side is bigger. All right, this means that we have an exothermic reaction. All right, so those are the steps you're going to go through. Do not skip drawing the structures because that's the #1 place students make mistakes. If you can't see what you're counting up, then it's going to be difficult to do it accurately. Okay. All right, so what I'm going to do, I'm going to stop the recording and I'll still be here. I'm going to turn off my iPad version of this and let you work on problem number 2 and problem number 3 and just turn your microphone on and chime in if you have a question and I will gladly help you out.